Good afternoon, ladies and gentlemen. This is your tutor, Mr. Mwamba. Yeah. So this is Math Week 10 Advanced Calculus or Math at 100, whatever, depends on the university where you are. So we have these 3 questions for you. So now the first question is obtain the first partial derivative of the function f x y, the integral of x squared y 1, the natural log of p dp. Then the other one is solve the initial value problem denoted by the Laplace transform d2y dx plus 9y equals 10, where the first line or the first derivative of 0 is equal to 0 and the y of 0 is equal to 0. Then the other one is evaluate the integral of the natural log of x dx. So we start with the first question solution. Right. So now the first question, they want us to differentiate, they want us to obtain the partial derivatives. So now what to do is say f x y equals the integral of x squared y 1 then ring p dp. So there, what to do, ladies and gentlemen, we are going to change this. For where there is dp, we substitute that. Then we split this. Where there is p again, we substitute 1. So I'll make it like this so that you understand. So x squared y 1 then x squared y minus then 1 then everything dp. So now since we have changed and we have substituted everything there, it will change to df like that. Since it is with respect to f, so it will change to df. So now as you can see, ln 1 is 0. So no wonder I wanted to show you how it's supposed to be. So ln 1 is 0. So we don't have any need of including that. So what it means is that we just deal with this, the integral of x squared y 1 ln x squared y f like that. So now this question, this means that we are going to differentiate this with respect to x as well as y. So now we are going to differentiate our df with respect to y and also our df with respect to x. So that will be our partial derivatives which they want us to find. So now what we are going to do in this case, we are going to introduce something which you need to understand, which is d dx, the integral of g of x equals a like that. So now once you do that, you need to understand to say this will be equal to the h of p dp equals h of g of x like that, then dot the g of inverse of x like that. So this is what it means. So what I'm trying to explain here, ladies and gentlemen, is that this a is the one which you are seeing there, then the g of x is that part which we have there, the x squared y. Then with respect to dp, so the h is the ring which is there. So where there is p, the p is there which we have, then the dp is there. So now here what they are trying to tell us is that if we want to obtain the partial derivatives of this question, we need to differentiate. We need to differentiate this with respect to x, then we repeat that part which is in the integral. That's what it means. So here we'll start with this, the ring x squared y. So let me create some space so that you understand what I'm talking about. Okay. So now we'll start with the df. df, or my f of x, or the df over dx. It's okay? Or we say df over dx, because here we are differentiating with respect to x and the y. So now let's start with the df, which is the f of x, f of x, like that. Okay. So now we need to differentiate this with respect to x. So now what are we differentiating, ladies and gentlemen? So we are going to differentiate this part, which is the g of x, g inverse of x. So in short, I'll make it simple like that. So we differentiate this part. We are going to use chain rule. We'll differentiate this part. So when we differentiate this with respect to x, we are only differentiating x, not y. So when we differentiate x squared there, what are we going to get? We are going to get 2xy, like that. So this is our differentiation with respect to x. Then once we do that, we need to say dot. Then we repeat what is inside the integral itself. So what is that? Is lim x squared y, like that. So in short here, you say the partial derivative of the xy, or the f of x equals 2xy lim x squared y. So that's our first partial derivative. So now we come to the second partial derivative. Create some space. Come to the second partial derivative. So the second partial derivative is for df of dy, because the formula is saying f of xy. So now we come to the dy. So which is the f of y. So in this case, we are differentiating with respect to y, not x. With respect to y, not x. So remember, we had lim x squared y, like that. Then f. So we are differentiating with respect to y, not x. So now when we differentiate this with respect to y, we are going to remain with x squared. So x squared, then we repeat everything which is in the integral. That's what the formula is saying. Then say lim x squared y, like that. Okay. So now this we then conclude to say x squared lim x squared y. So this is the partial derivative with respect to y. So now to conclude your answers, you say the first partial derivatives are x squared lim x squared y and 2xy lim x squared y, like that. So thank you for watching this video.